IP gateways. In the previous, we have discussed this is one network. Of course, the mask length is 24. Okay, when two computers connect together, okay, if you want these two computers to communicate each other, they first should be exist in the same network. Okay, if in the same network, then the computer will sending packet in the IP header. The source IP address should be itself, and the destination IP address should be this destination IP address. And if these two computers that not exist in one network, here, this example, these two computers just not in one network, then how do they construct the packet? First, the source IP, of course, itself, and the destination IP still this computer. But when this packet sending out, this host must know the destination IP is not exist in the same network. So this computer, host A, first we are searching for the gateway. The gateway is the exit point of this network, just as the door of this room. Okay, one network just as one room, and then this is as a door exit point, and of course this is another network, of course just as another room. And then when one packet in one network segment wanted to another segment should go to the door. That's the gateway. And then the router receiving this packet and then seeing in the destination IP. That's destination IP is this address, and then searching the routing table and then seeing this address is connected to this interface. Then the router will sending the packet out of this interface. Then the host B will receive it. This is the concept of gateway. Okay, if there's no gateway, the computers must configure use IP address with the same network part. Okay, they are in same network, they can communicate. If two computers configure IP address with different network parts, they cannot communicate. The computer will searching for the gateway. Okay. And then the IP headers. This is the IP headers. Okay, IP headers. This is the fixed part, and this is the option part. We have discussed the IP address detailing. Okay, IP address detailing, and then there are many other fields. We will discuss later. First, the versions. Of course, the IP packet is IP nowadays is IP version 4. Okay, and the header length, that's because there are the options. So the length should be 20 to 60. So you need to figure out what is the length of the header. Of course, usually it's 20. The DS field, DS means differentiated service. This is used to identify the grade of this packet. Okay, what is the preference of this packet? And the total length. The total length means the packet length includes the header and the data, the upper layer data. Okay, upper layer data. And then we go to the grid part. Okay, the identification fragment and the fragment offset. What is it used for? This is used for packet fragmentation. Fragmentation. What means the fragmentation? Fragmentation means the host A, when the host A sending out one packet, but when the router sending to another network segment, and in the previous chapter, in the Ethernet chapter, we know there is a concept of MTU, the maximum transmit unit. That means how long can a frame sending in this network? For example, in this network, maybe the 1,500 packet frame can send, but maybe in this network only 1,000 frame can send. So if the host A is sending out a 1,500 frame out, then the router should fragment this packet into different packets, into more than one packet. One is contained 1,000 and another contains 500. And then this packet can go to the destination. Okay, if the fragmentation happened, we need to the field to identify the fragmentation is happened, and then what is the sequence of each fragmentation. Okay, each fragment. Okay, then the identification is to identify these two fragmentation is in the same packet. It's the same packet. And the fragment to identify if the fragmentation is happened in the sequence. This is the first and this is the last. Okay, this is the last. Okay, and fragmentation offset means the first fragment, the offset is 0. Okay, this is the first byte in the packet, and the fragmentation of this is 1001. Okay, this is the offset is 1001. Okay, this is this three field used for fragmentation, and we should know how this field identify the fragmentation, and then the receiver can use this field to reassemble this fragment. Okay, this is the object fragmentation, and then another field, the TTL. That's the time to live. What's the time to live? Time to live just to count how many hops. Hops just means routers. How many hops the packet have passed. For example, when the host A sending out, the TTL use 8 bit. Okay, so the TTL, the maximum value is 255. And then when this packet passed one router, and then this value will -1. And then this is 254. And then another -1 again. Okay, and until if there's many routers, and then until the TTL reach 0, then this packet will be dropped, not forward again. Of course, nowadays there's no such networks that have more than 200 hops away, but maybe we will encounter such a scenario that the network is looped. That means the packet will forward between the routers again and again. Okay, this is a loop. Okay, that's loop means the packet will going through these routers recursively. Okay, never stopped, never stopped. And the TTL just a mechanism to forbidden the scenario that the packet will forwarding forever. That's after 255 hops away, then this packet will be dropped to minus the bad effect of the loop. Okay, this is the TTL value and how it is used. And then the protocol field. The protocol field, just like in the ether frame. In the ether frame, there are three fields: destination MAC address, source MAC address, and then the type. The type is used to figure out what is the data part carried. Okay, what is the protocol carried in data part, and the protocol also figured out what is carried in the layer 4 data. Okay, maybe it's TCP, maybe it's UDP, or maybe it's ICMP. The value figure out. If the value is 0, just figure out the data is an ICMP. If the value is 6, just means it's a TCP. If the value is, of course, this is hexadecimal. That's it. That's the 1 hexadecimal. Just in the decimal, it's 7. Okay. If the value is 7, just means the data carried in IP packet is a UDP. Okay, it's a UDP. Okay, the protocol field. And then we reach the end. Okay, and there are the 3 questions. Okay, we just see these 3 questions. What is the IP subnet mask used for? IP subnet mask used for separates the IP address into 2 parts. Okay, the IP address is 32-bit long. Use IP subnet mask, we can separate the IP address into 2 parts. One part is the network part. Okay, one part is the network part, and another part is the host part. Okay. Okay, this is the usage of IP subnet mask. In Class A, Class B, and Class C have a default network mask. And use the IP subnet mask, we can develop another mechanism we called VLSM. Okay, variable length subnet mask. Okay. Then the second question: what is the purpose of TTL field in the IP header? In the IP header, there is a TTL value. The TTL field is the time to live. This value will reduce when the packet reduced by 1 when the packet passing through one router. Okay, that's one to prevent when the network is looped, then the packet will forwarding forever in the network. But if there is a TTL value, then the packet will not forwarding forever in the network, will dropped after 255 hops away. Okay. How are gateways used in IP network? Yeah, we know in the computer there is an IP address. The IP address is divided into network part and host part. And the computers can only communicate with other computer that has the same network part. That's the in one network. But if the computer wants to communicate with the other host with different network parts, should forwarding to the gateway. Okay, should first forwarding to gateway. Okay, This is another network. So first should forwarding to gateway, and this is the function of the gateway. Gateway just to as the exit point of one network. Okay, and using the gateway, one network can connect to other different networks. Okay, and then we go to the end of this chapter. Thanks for you to join my lecture. Okay, goodbye.